Hello friends. In previous lectures we worked in center of mass frame. Now again I am taking center of mass frame for new question. This question is not new. It's very popular question. Different authors and teachers describe in different ways. Sure, there are so many ways in which we can describe, we can solve, but in center of mass frame that will be too much easier. So we are doing this question in center of mass frame. Okay. Firstly, understand the question. This is frictionless surface. I'm taking something upward. This is frictionless surface. There is no friction in this one, and there is a mass m1. There is another mass m1, m2. Sorry, both are placed on frictionless surface. These two masses are connected with massless spring. This spring is massless. Massless and relaxed. Relaxed means it has no elongation or compression. A stiffness of a spring means a spring constant is K. A spring constant is K. That's given to it. I am reiterating again that this entire surface is frictionless. Now everything is in rest, and at t equals to 0 a constant force F acts on M2 rightward. This force acts rightward, that is shown in direction. After applying this constant force F rightward on M2, we have to find out maximum extension or elongation in a spring. Okay. Since external force on this system is F, because there is no other friction, so acceleration of center of mass ACM will be net external force F, I am taking magnitude only, upon total mass of the system. Net force is F this one. Sum of external forces means sum of forces on M1 and M2 due to spring will be 0. Always sum of internal force for a particular system is 0. So only for acceleration of center of mass we should take external force, this F, and that's equals to m1 plus m2. Know one thing, this is acceleration of center of mass, but this is acceleration with respect to ground, and that is of center of mass. Okay. If we choose a frame of reference, means position of observer at center of mass, that observer will be accelerated. That frame of reference will be accelerated, and its acceleration will be the acceleration of center of mass, that is here written down, that is rightward. I am writing. So accelerated observer position, accelerated observer status, accelerated frame of reference is called non-inertial. And in non-inertial frame, bodies generally have pseudo forces. Here in center of mass frame, which is accelerated with this acceleration rightward, will observe a pseudo force on M1. What's that one? M1 into acceleration of center of mass, but in opposite direction. Acceleration of center of mass is F upon M1 plus M2. Acceleration of center of mass is rightward, so this direction will be leftward. Now, I am taking left. This is magnitude of pseudo force acting on M1, but direction is left. In the same way, the pseudo force on this M2, pseudo force force on M2. What will be that one? May you tell me? M2 into acceleration of center of mass F by M1 plus M2. But sure, that will be also left because center of mass itself is accelerated rightward. So this one will be left. Actually, there are two forces on this M2. One of them is pseudo force, that is leftward in this one value. This one is F. Then net force on M2 will be net force on M2. I'm just deleting this one. Net force on M2 will be F minus M2F upon M1 plus M2. Why? F is rightward, this pseudo force is leftward, so here minus sign appears and this is net force. Okay. Since in center of mass frame this force is towards left and initial velocity of M1 is 0, so this force will cause displacement leftward in center of mass frame. This force, pseudo force, will cause leftward displacement in center of mass frame. And suppose the maximum displacement of the same one in center of mass frame is x1. Suppose I am taking here x1 maximum displacement of M1. We need not to reiterate again and again about frame of reference, that sure center of mass frame. This is x1 is displacement of maximum displacement of M1 in center of mass frame. In the same way, since net force on M2 is acting rightward, pseudo is leftward, F is rightward, net force is taken rightward of this magnitude. So displacement will be rightward and x2 is maximum displacement. I am taking here x2 maximum displacement of M2. In which frame? In center of mass frame. Okay. It means we know every force on this system. We know displacement. We want maximum elongation in spring. What would be that one? This one displacement is leftward x1. Displacement of M2 is x2 rightward, that is maximum displacement. So maximum elongation is x1 plus x2. We have to calculate the value of x1 plus x2. That's our motto. Okay, we are doing. We should go through work energy theorem. We should go through work energy theorem. From work energy theorem, you all know change in kinetic energy, or we should say here कि work done by external force is equal to change in kinetic energy plus change in potential energy. Otherwise you can write down कि total work done, in total work done you will take internal force also, that will be negative of change in potential energy equals to change in kinetic energy. Both seems different but actually they are same. So we can write down कि net force total work done on external force is change in kinetic energy plus change in potential energy. The work energy theorem is stated in this way also. Okay. What about delta K, change in kinetic energy? At t equals to 0, velocity of M1 and M2 was 0. That is given in your question. So initial kinetic energy was 0. At the time of maximum displacement, if displacement of the same one is x1, that is maximum, and in the case of maximum displacement, rate of change of displacement will be 0. At any maximum quantity, rate of change of that quantity will be 0. So velocity is the rate of change of displacement, position, x1. And it is maximum, so velocity of M1 at that time will be 0. When x2 is maximum, velocity of M2 will be 0. At maximum displacement, certainly velocity will be 0. Right? in the same frame. Okay. It means final kinetic energy of this entire system is also 0. Final means when elongation is maximum and initial was 0. What about change? 0 minus 0 will be 0. This delta K will be 0. And delta U will be energy stored in a spring. Firstly, we are doing this. We are writing this W external force. Here pseudo force will be also assumed as external with respect to center of mass. So on M1, pseudo force is this one and displacement is x1. This force is leftward. Displacement with respect to center of mass is also leftward. So what about work done of pseudo force? x1 into m1 F by m1 plus m2. Both are leftward. So positive work done is work done due to pseudo force on m1. And that is work done on m1 force F upon m1 plus m2. I have already told you that this work done will be, this is force into x1. This work done will be positive. Why? Force is leftward, displacement is leftward with respect to cm, center of mass. In the same way, work done by external force on m2 will be also positive. Why? This force is rightward and displacement is also rightward in center of mass frame, that is x2. We will have here net force, this one, F minus m2 F upon m1 plus m2, this whole into, this is force, net force into x2. This is total work done, this one. This is work done on m1, this is work done by net force on m2, and that's equals to delta K is 0, this portion delta U, that's half K x1 plus x2 squared, half k x square. X is x1 plus x2, because we are writing this equation in the position when elongation is maximum, that is x1 plus x2. Okay, write down again this one. No, one thing, if you solve this one, I am writing m1 F upon m1 plus m2 plus x1 plus, if you take LCM of this one, m1 m2 F minus m2 F, what will be remaining? m2 F will be cancelled by m2 F, and this will be also m1 F by m1 plus m2. I hope you understand this bracketed part. This is remaining portion, because m2 F will be cancelled into x2. This is common in both one. That's equals to half of k x1 plus x2 squared. Okay, na? May I rub this one? If I am writing this one portion here, what about that one? m1 F upon m1 plus m2 is taken common from both. That's x1 plus x2 equals to half k x1 plus x2 whole squared. You can take this one cancelled. This x1 plus x2 upon k, that is half k. I'm sorry, that is half k. Will be remaining. And if you put this one leftward, what about this one? 2 m1 F upon m1 plus m2, that is k is x1 plus x2. This is our answer. Now I can this maximum elongation x1 plus x2, x max of a spring will be 2m1f upon k m1 plus m2. In some books m1 and m2 are given equal, in some books m2 equals to 2m1, that's why, but the sense will be same, sense of the question will be same, and we can calculate. Sure, you had gone through this question in other ways also, and I am very sure that you will feel this one very easier. Friends, time by time further I will take particular chapter and explain that one, and we will do very good question. I will describe entire syllabus of IIT, Advanced, Mains and NEET, also complete preparation of CBSE board. You have to go nowhere at all. The sufficient exclusive material and teaching will be here. Please share these videos and invite other your friends. Thank you. One thing, notes of this one will be given at my page Kamlesh Pandey classes associated with my Facebook Kamlesh Kumar Pandey. Link will be given this description box, through which you can reach that one that is page, and that will be very convenient. You need not to here note down, you can note down, but that's not necessary because its notes will be given at that page and it will be very convenient. So with complete notes you can have and you can observe this lecture.